Hello everyone, I am Noor Zainab and in this video we're going to discuss about the parallel combination of capacitors. We will also discuss some of the applications of the capacitors which are connected in a parallel circuit, and by the end of this video you will be able to derive the equivalent capacitance of parallel combination of capacitors. A capacitor is a device that stores both electric charges as well as electrical energy. The electric charges are stored in the plates of the capacitor, which are parallel to each other, whereas the electrical energy is stored between the plates of the capacitors in the form of electric field. The more the charge Q which is stored on the plates of the capacitor, the more the potential difference is created between the plates of the capacitors. Here C is a proportionality constant and is known as capacitance, which is the ability of a capacitor to store charge. If we are having two or more capacitors which are connected to each other in a parallel combination, what will happen is that all the positive plates of the capacitors are connected to the positive terminal of the battery, whereas all the negative plates of the capacitors are connected to the negative terminal of the battery. Because of this, all the three capacitors have the same voltage, which is equal to the voltage of the source supply, which is the battery. That's why in a parallel combination of capacitors, all the components have the same voltage. So now let's discuss some of the important characteristics of parallel combination of electrical components, whether it is a parallel combination of capacitors, resistors or inductors. These properties remain same. It means in the parallel combination, each component of the circuit has same voltage or potential difference. The second characteristic of parallel combination is that each component has different charge. Because of this, the current splits. The total current is the sum of the currents which are passing through each component. Parallel combination of circuits have many applications in our daily life. They are used in circuits in which the components are connected in a parallel circuit so that they can operate independently of each other. Furthermore, they are used in the power distribution systems where they ensure that if one component or if one part of the circuit fails, others can function. Whereas in a series combination, if one component fails, for example a resistor, a capacitor or an inductor, if one component fails, the entire circuit stops working. The entire circuit becomes open and the current stops flowing. This happens because the circuit components are connected end to end in a series circuit and the current has only one path to follow. An everyday example of series circuit is a string of lights. If one bulb of light burns out, the entire string will stop working. So here you can see the parallel and series combination of three different electrical components. And here you can note that in parallel combination, the capacitance, the total capacitance or the equivalent capacitance of the circuit increases, whereas in parallel combination of resistors, the equivalent or the total resistance of the circuit is reduced. So we can say that if we add capacitors in parallel circuit, their capacitance will be increased, whereas if resistors are included in a circuit in a parallel combination, the resistance will be decreased. So now let's discuss that there are three capacitors which are connected to each other in a parallel combination such that the positive terminal of the battery is connected to the positive plates of the capacitors, whereas the negative plates of the capacitors are connected to the negative terminal of the battery. Each of the capacitor is storing different charge according to its own capacitance. As we can clearly see that the positive plate of each of the three capacitors is connected to the positive terminal of the battery. So all the points here have the same voltage. Also, the negative plate of each of the capacitor is connected to the negative terminal of the battery. So all the points here have the same voltage which is present at the negative terminal of the battery. So here we can say that all the three capacitors have the same voltage which is equal to the voltage of the battery. It means that the voltage across the points A, B is equals to the voltage which is provided by the battery, which is V. So always remember that the voltage across each capacitor is same because all the capacitors are directly connected to the battery. Whereas all the three capacitors store different charge because they have different capacitance. They will store charge according to their own capacitance. As we know the formula, Q is equals to CV, where Q is a charge which is stored on the plates of the capacitor and C is the capacitance. So as the capacitance of all the three capacitors is different, they will store different charge. If we replace these three capacitors by a single capacitor, the single capacitor will be known as the equivalent capacitor and its capacitance will be increased and it will be known as equivalent capacitance. So now let's derive the formula of finding the equivalent capacitance of three or more capacitors. So here you can see that three capacitors are connected in a parallel combination to each other. The battery is providing the charge Q, which is split between Q1, Q2 and Q3. So we can say that the total charge Q is equals to Q1 plus Q2 plus Q3 up to Qn, where n denotes any number of capacitors. So in order to derive the equivalent capacitance, you have to remember that we will start the derivation from the charge Q. We will start the derivation from the thing which is different. It means that in parallel combination, the charges on each plate are different. So we are starting the derivation from charges. Whereas in series combination of capacitors, voltage was different. So we started the derivation from voltage. Okay, so in this equation, we can put the formula of Q, which is equals to CV, where C is the capacitance and V is the voltage. Here you can clearly see that the voltage of each capacitor is same, whereas the capacitances are different. So as the voltages are same, we can take the voltage as common. Now by bringing this voltage to the left side of the equation, here it will be divided. And both of these voltages can be cancelled with each other. And hence we get an equation which shows us the total capacitance of these three capacitors. And this capacitance is known as the equivalent capacitance. So we can say that when the capacitors are connected parallel to each other, the total capacitance of the capacitors is increased. Furthermore, the equivalent capacitance of the parallel combination is always larger than any individual capacitance which is present in the circuit. So in this way, we have derived the equivalent capacitance of capacitors which are connected in a parallel combination. Here n denotes any number of capacitors. So in order to derive the equation for the parallel combination of capacitors, always remember these 3 points. That number one, in parallel combination the voltage is always same. You can remember this by P for potential difference and P for parallel. So in case of parallel combination, potential difference is always same. Number two, current splits. It means that different charge is present in each capacitor. And number three, there is an increased total capacitance. The total capacitance of the capacitors is increased in a parallel combination. If you have any questions, you can ask in the comment section. And thanks for watching, and don't forget to like, share and subscribe to my channel for more videos.